Hello everyone, myself Rohini. Today I am going to discuss about the topic photolithography. Photolithography is a patterning process in which a photosensitive polymer is selectively exposed to light through a mask, leaving a latent image in the polymer that can then be selectively dissolved to provide patterned access to an underlying substrate. Photolithography process can be classified according to the type of light used, such as ultraviolet, extreme ultraviolet, or X-rays. The wavelength of light used determines the minimum feature size that it can impress on the photoresist. Photolithography is a subclass of microlithography, the general term for process that generate patterned thin films. Other technologies in this broader class include the use of steerable electron beams, nano imprinting, interference, magnetic fields, and scanning probes. On a broader level, it may compete with directed self assembly of micro and nanostructures. Photolithography shares some fundamental principles with photography in that the pattern in the photoresist is created by exposing it to light either directly by projection through a lens or by illuminating a mask placed directly over the substrate as in contact printing. The technique can also be seen as high precision version of the method used to make printed circuit boards. The name originated from a loose analogy with the traditional photographic method of producing plates for lithographic printing on paper. However, subsequent stages in the process have more in common with etching than with traditional lithography. Applications of photolithography. It is commonly used to produce computer chips. When producing computer chips, the substrate material is a resist covered wafer of silicon. This process allows hundreds of chips to be simultaneously built on single silicon wafer. And the resolution. Photolithography can be used to produce features as small as 50 nanometer. Resolutions below this are limited by the wavelength of light. Other similar techniques like X-ray lithography and extreme ultraviolet lithography use short wavelength X-rays and UV light to achieve lower resolutions. Greek version of word photolithography, where photo means light, litho means tone, and graphy means writing. And I think you can see the picture. It is the basic procedure of photolithography. It includes steps like prepare wafer, apply photoresist, align photo mask, exposure to UV light, develop and remove photoresist, exposure to UV light, etch exposed oxide, and remove remaining photoresist. The procedure described here omits some advanced treatments such as thinning agents or edge bed removal. The photolithography process is carried out by the wafer track and steppers or scanner, and the wafer track system and the stepper or scanner are installed side by side. Wafer track systems have been replaced by coating developing systems which perform the same functions. Cleaning. If organic or inorganic contaminations are present on the water surface, they are usually removed by wet chemical treatment. Etching. In etching, a liquid like wet or plasma like dry chemical agent removes the uppermost layer of the substrate in the areas that are not protected by photoresist. In semiconductor fabrication, dry etching techniques are generally used as they can be made anisotropic in order to avoid significant undercutting of the photoresist pattern. Wet etch processes are generally isotropic in nature, which is often indispensable for microelectromechanical systems where suspended structures must be released from the underlying layer. Photoresist removal. After a photoresist is no longer needed, it must be removed from the substrate. This usually requires a liquid resist stripper, which chemically alters the resist so that it no longer adheres to the substrate. Alternatively, the photoresist may be removed by a plasma containing oxygen, which oxidizes it. This process is called ashing and resembles dry etching. And here my photolithography is completed. I think you can observe about applications of lasers. Thank you.